So we have a tree that grows in a very specific way. In spring, it doubles in size, and in summer, it grows by 1 meter. So let's say we start by 1 meter, a 1 meter height. So spring comes, it doubles in size, so now it's 2 meters. And then summer comes, so now it's 2 plus 1, 3 meters. And then spring comes again, so now it's 4 plus 2. We double the size, so it's doubled in spring. And then summer comes, and now it's 4 plus 2 plus 1, which is 7. So the next spring comes, now it's 14, then summer comes, now it's 15, and then it goes to 30, and then 31, and so on and on. Given the height, the initial height of 1, and given the age of the tree, determine the height at this age. So the initial height is always going to be 1, and we just need, given the number of cycles that the tree has lived, we need to determine the height. And the number of cycles means, so spring is 1 cycle, summer is 1 cycle. If we have 2, it means 1 spring, 1 summer. If we have 3, it means spring, summer, spring, and so on. So it could be odd, ends with a spring, could be even, which ends with summer. It could be anything. And of course, keep in mind that it could be in any range. So basically, you might expect the input to be in millions or billions. So basically, any positive integer could be expected. Okay, let's go for the slow bad solution first, just to make sure that we have understood the problem correctly. And then we can go to the optimized solution. So basically, the bad solution would be to have a for loop from 1 to the number of cycles, and then check. If it's odd, it means spring, so we double. If it's even, we add 1 to the height, and then we run this program, check the test cases, and if we pass everything, it means we have understood the problem correctly. If the result is correct, we're not talking about the runtime. Now let's check the optimized solution. So let's take a look at this pattern. At cycle 0, it's 1. Cycle 1, it's doubled, so it's 2. Then it's 2 plus 1. And then it's 4 plus 2. And then 4 plus 2 plus 1. And then it's doubled again, so it's a plus 4 plus 2. So we notice that we are adding powers of 2. Which means, so we have 1. It's basically, power of 2, 2 power 0. And then we have got 2, which is 2 power 1, and then 4, which is 2 power 2, and then 8, which is 2 to the power 3. So we are adding powers of 2. Well, this sounds like we have the maximum of a binary integer. Like, let's say if we have 3 bits, the maximum of 3 bits is going to be 7. The maximum of 4 bits is going to be 15, and so on, which is basically 2 to the power of n minus 1. 2 to the power of n also means the summation of all the powers below n, from 0 until n minus 1. Okay, it seems like we are halfway done. And now we can check how exactly are we going to calculate this. So the number of bits, or the number of powers we are going to add at 0 is going to be 1, which is like 1 bit. The maximum of 1 bit is 1. At 2, it's 2, and then at 4, it's 3, and then at 6, it's 4, and then at 8, it's 5. What kind of pattern is this? Well, actually, it's like we double every year, right? So we add 1 bit every year, and every year is 2 cycles. So we need to divide this by 2. So we get the number of years, the number of times you have doubled, and then we're going to, well, it looks like we just need to add 1. So instead of 0, we need to be at 1. So now we have got this pattern figured out. So basically we just divide the number of cycles by 2 and add 1. That's how we get our n. And then we use this as a power of 2, and then minus 1. That's how we calculate an even cycle. Well, what about the odd cycles? Well, from the problem definition, we know that the odd cycles are just the even cycles times 2, because we are always doubling in spring, which is the out cycle. So we just have to solve the problem this way. If it's even, we have this equation. If it's odd, we double the result of the previous cycle. And that's how it's done. See you in the next algorithm.